Hello, everybody. I'm Mario Linhares, and this is a new SIPS of Science. This is episode 10, and today we're going to talk about physics. We're going to talk about, we have two international guests here, Professor Hardev Singh Virk and Professor Sukhmander, I think that's how you pronounce it, Sukhmander Singh. I'd like to welcome everybody for this show. And of course, we have with me Dr. Florian Kongoli. I would like to invite everybody to subscribe to the channel. This is a joint production between Flogen Star Outreach and TV Onda Azul from Brazil. I'm broadcasting from Brazil, and our guests are in Japan and California. So let's start tonight's show with the opening of SIPS of Science. Hello, everybody. I'm back. I'm Mario Linhares. I'm broadcasting from Rio de Janeiro, Brazil. And I've got in the Bay Area of San Francisco, in the Silicon Valley, two of our guests, Professor Singh and Professor Virk. Yes. And also in Japan, I've got Dr. Florian Kongoli. Let's start with Dr. Florian Kongoli. Good evening. Well, it's good morning for you, right, Doctor?
Good morning. Good morning. 7 o'clock in the morning, Japan time.
Very good. Well, in Rio de Janeiro, it's 7. We are like 180 degrees on the other side. Yes, so
7
here is
p.m.
7 p.m. Yes, it's 7 a.m. And I would like to welcome our guest, Professor Virk. Hello, Professor Virk. How are you? You are in the Bay Area, right, in San Jose, right?
Yeah, it is good afternoon for me. And
what time is it?
Yeah,
3 p.m., I guess.
3 p.m. Yeah.
3 p.m. Very good. And in the same time zone, we've got Professor Singh. Hello, Professor. How are you?
Welcome. Hello. I'm also in the Bay Area, about 3 p.m. afternoon.
Very good. Well, so let's start. We are going to talk today about one of the most important symposiums we are having in SIPS. Yes, we are talking about SIPS, for you guys know, it's the Sustainable Industrial Processing Summit and Exhibition Sustainability Through Science. It's going to happen from the 27th of November to the 1st of December in Phuket, in Thailand. And on this episode, we're going to talk about the Virk International Symposium on Physics, Technology, and Interdisciplinary Research for Sustainable Development. And I would like to have Dr. Florian Kongoli to talk a little bit about SIPS and specifically about this international symposium. Hello, Dr. Florian. What can you tell us about it?
Yes. So as you know, SIPS is a 360-degree summit. It includes many fields of science, starting from the geology, minerals, processing, refining, developing new materials, advanced materials, nanomaterials, intelligent materials, technologies in medicine, technologies in related to COVID, and you name it. So also we include the law. We have a specific symposium dedicated to Washington, D.C. lawyer at SIPS in Phuket. So as a 360-degree symposium, okay, one of the fundamentals of everything we're speaking about, of this 360 degrees approach. This is basically physics. Physics is at the fundamentals of everything, basically. And sometimes there are jokes between chemistry and physics, which one is most important, and which one is first, and which one is origin, and which one it is, which follows. Normally, the physics, normally the idea is we start with physics, and chemistry follows the physics, because chemistry is because of reaction of different materials based on structure, physical structure, etc., and physical interaction. But that's we're not going to get to this subject. I mentioned this in order to make it in order to make it in the context of sustainability, Flogen sustainability framework, where on which SIPS is based. There are three criteria of sustainability. As you know, it is protection of environment, it is development of quality of life of human being, and also economic development. That means economic growth. And here, physics, physics is normally it fits to all of them in environmental protection, in economic growth indirectly, and also in development of human life. But also, these three criteria have to be simultaneously achieved. Being simultaneously achieved, this is the only condition that makes you sustainable. But who are the actors or pillars that can hinder or help sustainability? And according to our framework, there are three: science and technology, government and management, and education of civil society. Professor Virk and physics enters at science and technology and education and civil society. So we have government and management. It is related mainly in this particular broadcast. We don't have any politicians, so the management is basically industrial companies that apply physics in their daily operation. So here is the context, and Professor Virk is a physicist. There are misconceptions that physics is just a theoretical science only, which it is, but it's not only, because physics is applied to everyday life in any field of life. So it's not just theory. It is also applied to everyday life. So this is the context of Virk International Symposium on Physics and as a function of sustainable development. So physics can be applied, and Professor Virk has applied this in minerals, polymers, and also in analyzing the soil, air, and other aspects of life in order to serve the environmental protection. But also he has applied physics in prediction of earthquakes in various countries. So as I said, physics is not just a theory that just stands in the air, but can be applied. And this is the purpose of SIPS, to bring together the fundamental science with applications. Because as you know, unfortunately, 99% of our academic papers today stay in the shelf of a library without seeing the light of application. And SIPS is trying to change this. And this is what we are trying to do.
Very good, Professor Dr. Florian. I would like to talk to Professor Virk. Dr. Florian started introducing you, but I was looking at your biography here. Yes, you've received a bachelor degree with distinction from the Punjab University, and master's in physics with specialization in elementary particles from the Aligarh Muslim University. And you started your teaching career in an engineering college in 1963. And you got your doctorate, your PhD in high energy nuclear physics from the Marie and Pierre Curie University in Paris. And there's a lot more, but basically you've traveled through 50 countries for your academic pursuits. You would invite everybody to check the full biography here at the link at the description. Yes, if you're watching on Facebook, you can get it on Facebook, on YouTube, LinkedIn, but all the links are here. You have a very impressive biography, Doctor and Professor. Virk, welcome, and thank you very much for this opportunity. How are you?
Thank you, Professor Mario, for introduction. Actually, I feel honored that Dr. Florian Kongoli invited me for organizing Virk Symposium. And, I have been connected with the SIPS series of conferences since 2013 when I was invited in San Diego conference. I have read the history today and I find that the series of six conferences were started after 2002. And if we go to the history, we find there have been 11 summits and 5,000 presentations where 23 Nobel laureates they have attended. And in the forthcoming summit at Phuket, Thailand, 9 Nobel laureates have been invited and they have accepted the invitation. So it is a great effort being made by Florian Kongoli to promote sustainability, development of a model with the help of science and technology. My work, as you have cited in Marie Curie University of Paris, it was on a very fundamental subject, which is known as elementary particles. Had I continued, I could have my publications with the discoverers of the Higgs boson or God particle because I was in the same laboratory. But after 2 years of my training, I had to return back to India where there were no high energy accelerators. So I had to change my field. My first love was radiation biology. But, I was not good in biology, so I started another interdisciplinary area in 1974, which was geochronology, fission track dating of rocks. Now, this area, it comes under geochemistry. Then I had to study a lot of geology and geophysics to extend applications of my knowledge in interdisciplinary physics to earthquake studies, to radon studies and helium studies as precursors to earthquakes. Florian was asking about radiation damage. The application of radiation damage is everywhere, starting from X-ray and then going to hospital. You need these radiation sources. So I shifted from geology and geophysics to radiation damage studies in basically minerals, then glasses of all types, and then we shifted to polymers. And surprisingly, this area has a lot of application. You can
Okay.
change polymer to a material which has strength as much as steel. And this area, it has given us a lot of publicity because we have 120 research publication in journals in radiation damage and all type of material. And a model which was tested by Professor Price in UC Berkeley in space shuttle experiment. They wanted to study effect of cosmic. Actually, the work which we were doing on polymers or glasses, it has applications in extraterrestrial studies when space shuttle goes and astronauts they fly, they are subjected to galactic cosmic rays. And this model they found it's theoretical. We developed it experimentally, empirical formula. Professor Price interpreted it theoretically, and they found that it is useful for protection of the astronauts.
Okay.
I, our paper is one of the 250 papers which were used for making space suits. That is another credit which we get.
Mhm.
So if you study our publications on a SearchGate, you will find that the work which we did on radiation damage in polymers and other materials, it is being applied for creation of spacesuits for astronauts. Now, in Virk Symposium, I selected 10 topics, starting with the fabrication of new material, because I was lucky to have seven co-sponsors or co-authors for this. So I found that Dr. Gurtej Singh Sandhu, who is working for Micron, he has a record number of patents in in semiconductors, almost going beyond 1400. So this topic was included because Gurtej Sandhu was interested in this symposium. So then nanotechnology, some of these topics have overlap with other symposia, and we have got 12 abstracts. Of course, two are in the field of nanotechnology, but the area which I started after radiation damage studies, it was use of radon gas and helium gas as precursors to study of earthquakes. So we have got three publications or abstracts for this Virk Symposium. One is by Professor Singh, who's an expert in dam studies and effect of earthquakes on dams. Then another from Israel. This group is
Uh-huh.
working. So they have given one abstract, and hopefully they will attend. So after this study, which is going on in India in thermal springs, radon helium, the sources of again uranium. So we did lot of work in uranium in soils, and then we were interested in radiation health hazards. So
I
in
see.
our state in India,
Uh-huh.
Punjab, we find that what is this? There is a lot of uranium in groundwater. There is a fluoride, which is also anomalous and quite dangerous for the health of children. And then arsenic studies. So we find that the sources of uranium, arsenic, selenium, basically it is geogenic, because in the northern part of our state, we have got the Shivalak range, the lower range of the Himalayas. So
Okay.
in 74, when I was just searching for a field to start my interdisciplinary research, I went to Kathmandu, right to the feet of the, Mount Everest. We collected our
Oh, very
samples.
interesting. Very, very interesting.
That was really going to the field. I always like that is why you say I have traveled through 50 countries collecting samples, meeting scientists, delivering lectures. So in Kathmandu, Nepal, we were lucky to collect samples, and the results which we got using fission track dating. This technique was again developed by General Electric, three scientists. Professor Price is living, the other two are no more, but they missed the Nobel Prize. This is simple technique which any developing
I
country
see.
scientist can do. And we found the results of Himalayan rocks. This is known as a reverse metamorphism.
Mhm.
Everybody, geologists and earth scientists, they were critical of our work. They knew that the Mount Everest is still rising. But what is the reason? That because other mountains in India, Aravalli and in South India, they are stable, rather going down. But
Mhm.
Himalaya, the height is increasing every year. So the reason was the rocks at the top of Himalaya, they were older, but due to metamorphic, changes, younger rocks were buried. So this was a new phenomena which is called reverse metamorphism.
I see.
So
Professor, and are we going to be? Are you going to show this, to talk about this at the symposium?
yeah,
All this.
so if you allow Professor Singh, then I will again come to our groundwater studies
Okay.
after Professor Singh he tells about his studies.
No, but I mean, I'm asking because this is very interesting. I'm very impressed with this. But I would like to hear a little bit about Professor Singh. What we can expect at the symposium, Professor.
Thank you
Professor
for that.
Singh?
I just
Before, sorry,
restructured.
I would like to introduce you. Yes,
Oh,
technically,
that's
because
okay.
yeah.
Go ahead.
So we've got here Professor. How do you pronounce your name? Sukhmander?
Sukhmander is
Sukhman.
perfect.
Okay, so Professor Sukhmander Singh had his master's from the Indian Institute of Technology, Delhi, and PhD degree in civil engineering from the University of California, Berkeley. He worked as senior project engineer with a top consulting company in San Francisco and worked as principal investigator of the prominent projects such as a dam with the history of slide and its redesign. And all his biography, I mean, part of his biography, not all, a small part of his biography, you can find in the link that we left here in the description. So, welcome and thank you very much, Professor. It's an honor to be talking to you.
Thank you very much. Actually, I restructured my talk just now after hearing Florian, Doctor. Of course, the focus is on sustainable development.
Uh-huh.
And Professor Florian Kongoli has presented three criteria or three requirements for a sustainable development. I will take up from there. He suggested that these are to be met simultaneously. For example, he said, environmental protection, then economical development, as well as social development. The way I'm planning to present these three criteria, their application actually is different if we're dealing with highly developed nations, and this criteria will apply differently if we're dealing with a developing nation which are poor. Of course, recently all this, unexpected heavy rainfall, drought, they all have, globally put all of us on a focus for environmental issue, and hence maybe that's why it's extremely important. Better focus more on it. How can we sustainably live? Because as the GDP want to increase, that would mean we're going to exploit more of our resources, create more pollution, and to keep in a safe standard of living. That cannot be sustained the way it is. That creates greenhouse. So now we are at a juncture. We must woke up that our current way of living, standard living, just cannot be sustained. How then we keep developing and yet develop in a way so that we can, as Dr. Florian said, keep environmentally protected, yet economically progress at the same time, socially. Okay, let's now start with first, as far as developed nations. Developed nations have already doing some attempt by some way of coming up with the pollution-free energy resources like wind, hydro, geothermal, and solar. They, however, are at a position they can put more emphasis in the money to develop more efficiency in these pollution-free approaches. At this time, they are economically still lagging behind. The other thing they can do is focus on biomass and even fusion. This could be an enormously big stride. Now, for a moment, holding on to this one, if the developing nations, where in some places there's a poverty, hunger, poor sanitations, they are more concerned about economic growth rather than protecting the ecosystem. Understandably, because they need to feed the people.
Exactly.
That's where the conflict is. Whereas the developed nations, for them, some are control, other things are understandable. But to apply those in the poor and developing country, it'll be a luxury. So how do we handle it? So for a moment, I'll focus on, for your attention, on the developing nation. Let's go with that first.
Okay.
Now, I have initiated some research also on that. The approach will be as follow. That granted, we must try to develop environmentally acceptable, economically accessible. I say accessible. We don't want to develop a country where you come up with a new production, an extremely powerful entrepreneur comes in and makes a lot of money, and the poor people remain poor. So there should be economically accessible to all, and socially sustainable means the poor people should gain out of it. I give you an example, practical example. I was in El Salvador. El Salvador's main crop is sugar cane. They burn the sugar cane waste, creating an enormous amount of pollution. That's one. Secondly, most houses, 99% of the houses, are built with concrete bricks and metal roof, completely inconsistent with the humid and hot climate. You're from Brazil, you can understand that.
Yes.
Now, preparing those concrete bricks needs cement. Cement needs lots and lots of energy, coal, those, and they create an enormous amount of pollutions. The metal. So I looked at it. Now, El Salvador is founded on volcanic ash. Volcanic ash is very plastic clay. So I suggested, I had a discussion with the UCA. You know, UCA is University of Central America. They
Yes.
have campus there. We were the dean. I said, look, because I had applied this method in India too, with the rice husk and those. I'm coming to that in a second. I said, shred that sugarcane waste, mix it with the clay, mold bricks out of this, insulated bricks, lightweight. Instead of
Excellent.
concrete bricks, use those. They will stay nice and comfortable in winter and up. Now you can imagine shredding, you need a lot of labor. Mixing, lots of labors. Molding bricks, lots of labors. So those poor people will find an employment base.
Exactly.
And look, the way we have environmentally come up with a very safe way. So therefore, my approach is this. By the way, the dean visited us at the Santa Clara University. One of their PhD students is now working on this project. The way I'm proposing is this, that these are the things which actually require a careful, deep insight into natural resources of a country, including the people, their skill, and then develop methodology consistent with that. That's how you can develop these things. You can't apply a one sweeping thing, It's another practical example. The similar example comes in India because there burn rice straw and those whole things. All exactly the same can be applied in India too. They can mold the rice waste and serve it in clay bricks and so on and so forth and bake them in small kiln. Now I was in Kazakhstan. Kazakhstan is a cold country. In the winter, it lots of below freezing, and then it turns out the upper ground, because the atmosphere is -20, the upper 78 feet of soil also freeze. Now, it turns out most of those soils are silty clay. Those fine particles have capillary effect. Professor Virk would know that attract moisture. The moisture migrates up from the deep ground to the surface soils, and by touching those frozen soil, the water freezes, expands, and creates a lot of cracks in their highways.
Okay.
When comes spring, the very first melt, that water melts away, then those roads sink differentially. Lots of damage. Too much money to be spent on this thing. I said, okay, I met the head of the geotechnical guy. I said, look, this is a simple thing. In future, the base below the asphalt should be of gravelly soils, because clay soil create capillarity effect. Gravelly soil don't. So if they freeze, they will not attract the moisture, and the moisture will not increase. So they are also working on this project. I'm giving you this
Very interesting.
two simple example, practical application of those things. Now coming back again to developed countries, we are in the US or the kingdom. Now there's a lot of tussle going on here, because fossil fuel uses and those things. I apologize if I make a very strong statement.
Okay.
Capitalistic statements, great, but it has its own problem. It breeds greed and try to monopolize the resources. There are more and more manipulation and more strength. There will be big hurdle in making a switch to those environmentally safe means of energy. Back at our own university, we tried a concept which is called a new what's called recycled material, energy efficient material. Even we went to Ghana as far as this. Take example, Ghana. Ghana is a country which is relatively poor. The people are living at such low level that there are some very low level people. They use local soil, which is called lateritic soil. They make bricks out of them, make their houses, put a tin roof on it. But that soil is notorious with the cycle of wetting and drying. Third year, so they collapse. So
I
we
see.
looked at it, they got it. I said, okay, we can find a solution for them, and also when we can employ people. So we somehow, cut the long story short, found a mixture by which those bricks can be molded. And then rather than building, see, listen now, they're poor. They can't afford reinforcing bars for the roof. They can't afford, cement, those things, So we developed an arching system. In an arching system, everything is compression. So those bricks,
Okay.
I have pictures where we had those people do, and they actually build it. They're building the arch, they're showing it, they're very happy. Our team was there. It's an enormously pleasant experience as well as for them. So all I'm saying is, in summary, for the developing countries, we must, before we apply, my apology, Dr. Florian, your criteria is well spoken and well done and got to be used.
Very good. Thank you. Dr. Florian, would you like to comment about this before I'll call a break? And we'd like to show a little bit about SIPS. But very interesting that Professor Singh basically talked about the sustainability framework and how effective it is.
Yes, because he hit the nail on its head, meaning that the criteria in this criteria, although they are applied separately and in different ways in different countries, so the core of the criteria are the same. So as we used to say, if we protect the environment, but we forget economic development, economic growth, and if we forget the quality of human life, we are not sustainable. There is no sustainability. So if you keep people poor and you protect the environment, and then the quality of human being, the quality of life goes down, then you are not sustainable. So if in developing countries, if you are saying to people protect the environment, but you just suffer in the quality of life, or prevent the economic development, then you are not sustainable. This is a big misconception. That's why the sustainability framework of Flogen has been so successful. So these are the three criteria. But which makes this this has to be fulfilled simultaneously.
Exactly.
Professor Singh would like to make a comment about this.
This has to be done simultaneously.
Sure.
You said it, Professor Loring, exactly. Wonderful. I was about to say that. Your criteria.
Sorry, could you repeat that again, Professor?
Pardon?
Could you say that again? Because I
say again. Yeah, but just Professor Florian said, I was about to say the same word. He said it so well. yes, these three criteria must be simultaneously applied and sustained. Otherwise, as you said, and I also said, if we only go after what you call it, speed with the heavy production, with some rich entrepreneur, that will leave the people not, as they say,
I see.
socially challenged. That's just main. So at the same time, if we also apply environmental means by which we ignore the other aspect, because the environment could be so stringent that won't let you grow or develop any development, no economic development, that can be impeded. So therefore, there should be such a balance and simultaneously applied. This is a wonderful way. And that's exactly I said. Once I heard your Florence this thing, I restructured my way of presentation. I said, I think it's a wonderful thing to use his initiative and apply them is absolutely useful and extremely well said, right on time, right on the nose.
Very good. Well, this is SIPS of Science, and I'd like to mention here some. We had some comments here. I would like to say hello to Mr. Adalto Oliveira from Inmetro. Yes, he's a big fan of Dr. Florian. He's watching, so I'd like to say hello to him and the National Institute of Metrology in Brazil, and also the Brazilian Society of Metrology. He's a big fan. He's always here. And he told me we had lunch this week, Dr. Florian, and he told me that he's looking forward to going to SIPS in November. So we're looking forward to meeting everybody from Inmetro there. Well, we're going to make a quick break because I would like to show you guys a video from Phuket, because I always tell Dr. Florian that P of SIPS stands for paradise, and I would like to show you a little bit what waits for you in a couple of months, okay? Well, we are back with the SIPS of Science, and this is Phuket Island from the 27th of November to the 1st of December in Hilton, Phuket, Arcadia. We are going to have there 600 scientists from all over the world, 600 scientific papers, and in between the scientists, among the scientists, 9 Nobel laureates. And I would like to talk again to Professor Virk to what we should expect there.
Yeah, just to make a point.
Yes.
So
sorry.
what we said, building on what Professor Virk and Professor Singh said, just to make the point, physics is not just it's a very important point. It's not just a theoretical subject. It can be applied, and we saw from what Professor Virk has done. So he has applied physics in prediction of earthquake. This helps directly the human life, human quality of life. If you are able to predict the earthquake. So if you are using different radiation technique to protect the environment, this is direct application of physics. And also, if you are using the physics to make polymers as strong as steel, this affects the CO2 emission when we produce the steel. So if we have polymers and steel, so we can choose. These are big development, and all this will be presented at Virk International Symposium. So anyone with similar research in all these fields, applying physics or also fundamental physics. It doesn't mean to be directly applied, because if you have a discovery, the application of physics could be in years from now. Still, we equally welcome fundamental science and application, and this SIPS that makes the link, because we bring together in one roof all fields of science. Science is one. So that's why our symposium on physics is very important, because this is related basically to all other symposia we have in SIPS, because physics enters everywhere. So now with more details and more specificities, is better Professor Virk to speak about this.
Yeah.
And I wanted to return after to the P that you mentioned, because I am in one P here, paradise.
Oh, you are. We are going to talk about that for sure. Before we
Yeah.
end tonight's program, you're going to tell us about this beautiful beach we visited, but we haven't shown on this program. So I'd like to talk a little bit about this. But Professor Virk, Dr. Florian mentioned something that I'm a journalist, I'm not a scientist, but he told me he's just said something that I was very impressed. And I'm going to be very honest. My knowledge of physics stopped in high school, so I don't really know much. But talking to the general public, how can you predict earthquake using nuclear
models,
energy or
physical models,
radiation? Physical model. That's it. That's the word, Dr. Florian. Thank you very much.
Yeah. Thank you, Dr. Florian Kongoli. In our seminar, we have got a lady, Mario Burgos from Venezuela. Now she has settled in Argentina. She will talk about applications of quantum mechanics to computers. So fundamental science is being used in, applications also. Now, you ask for application of physics or what we are doing in earthquake prediction. Everybody knows that prediction of earthquake is almost difficult, and still we have not been able to achieve the success in a given window of time and space. You have to, and the magnitude also. What we did, that we started in India as a leading group, that the radon which is being, emitted by the radium and uranium, it is present, it is ubiquitous everywhere. So in mountainous areas, there is more of uranium, especially in Shawalik ranges. So we have dug holes from 60 centimeter to 1 meter and put our detectors. There are about half a dozen detectors. The simplest one is polymer. This polymer is, fabricated in France, Kodak Pathé. It is a company which was making films for photography. So special polymer, which is called cellulose acetate, that was the strips 1 centimeter square you can cut out from the sheet, and if you put in hole for 1 month to 6 months, depending upon the area. So after taking out these small strips of polymers, we etched it in sodium hydroxide, which is rather, a high school student can do this experiment. When I came to Canada for a longer period this time, my son set up a laboratory at our home because it was not feasible to ask for microscope from the high school where my granddaughter is studying every weekend. So I am doing this work on study of radon, uranium in lakes of Canada. There is a special district, Kelowna. Those lakes are popular tourist resorts. So they are quite safe, but we have applied our knowledge to study radon and uranium in Fraser River and other. Anyway, going back to India, where there is a lot of uranium in the Himalayan, origin. So, starting with the polymer detector in 1984, then we had a lot of money provided by the Department of Science Technology. So we had sophisticated electronic counters. They are based on solid state, techniques. So 3, 4 types of detectors are available for instantaneous measurement of radon, or you can have a probe for 30 days. The fluctuations of the radon, let's say if there is a seismic activity in the neighborhood within 300 kilometer, then there is the radon activity will increase suddenly due to the this seismic activity. So whenever there is an anomaly of radon emission in an area, we could doubt that it is due to some earthquake which is developing within 300 kilometer. So depending upon the signals, we have correlated our radon anomalies or radon peaks in the data with the seismic activity. This is called micro-seismic study. So wherever there are dams, Mr. Professor Singh knows that we have Pong Dam, we have Bhakra Dam, and other dams in India. So the safety of the dam, it depends upon that what is the magnitude of the earthquake. Normally they built dams for resistance up to 7. They can tolerate 7 magnitude, but the earthquakes which came in Kangra Valley, it was 8.5. So there has been always danger. Now, groundwater studies we have been doing presently in our Punjab state, and there is a lot of heavy metal contaminants as well as arsenic and even mercury. So we found that these heavy metals, they are coming, have been deposits in the sediments for maybe more than a million years. With the flow of with the drainage system, there are many rivers, and recent flooding in Pakistan. This is another interesting phenomena. About 3, 4 days I was studying that the glaciers which are lying, from which the rivers emanate, those glaciers are melting at a much faster speed.
I
So
see.
the problem of sustainability, Dr. Florian, he has written 2 model paper in 2016 and 2017, and I read these model papers before preparing for today's talk. That scientists or economists, especially Malthus and others, 4, 5, he has given reference of the books. They predicted that the world will come to an end, especially India cannot survive because the population has crossed, 1 billion. So this was a big danger, but he has also proved that all those economists and scientists, they have been, uh, they proved their predictions have proved to be a failure because science and technology has come to help the growth of the population. The food production has increased and other facilities, but climate change, as Singh has also pointed out, it is the greatest danger. We have seen the effect of high temperatures all over Europe, and in India and Pakistan, the temperature they touch almost 50 degree. And now meteorologists, geophysicists, they link the recent flooding of Pakistan with the climate change.
I
So
see.
I believe that this climate change control, as Professor Singh has
Mhm.
already given examples of El Salvador and Ghana and India, so more stress should be laid over control of climate change. And for your information, we have got a paper from Venezuela by uh, Professor Bose.
I
They
see.
are making fusion reactors, small scale fusion reactors from the space flights, And another application which Dr. Florian was mentioning, but because if you compare steel and polymer is much lighter, and by radiation you increase the strength of plastic. You can make your spaceships. Most of the space suits, they are already made out of these polymer materials. So that is the advantage which I see of the study of radiation damage in materials. Groundwater studies are very fascinating, which we are
Mhm.
doing in India, in our state. And last but not the least, the history of, this topic I have included for first time, history of science and technology
Sorry,
for
the what?
history
History.
of science and technology for
Okay.
sustainable development.
Mhm.
I wrote to a German professor who is Indian. He was
Mhm.
asking money, $1,000 for my paper. I ignored him. But fortunately, I find there is a professor in Nepal. He
Mhm.
is teaching in some college or university. He has sent a paper on history of science technology development. This is so we should side by side study the history of development so that we understand how much progress we have made by
That's great.
organizing these conferences.
Very
So
good. Sorry, Professor Singh. Uh,
Yes.
these applications that Professor Virk said, uh, would you like to make some
Yes,
comments on
yes,
it?
yes.
I mean,
I would like
please.
to say something, because again, as
Mhm.
Professor Florian pointed out, application of physics.
Yes, exactly.
I'm a Berkeley graduate, and we are spending an enormous amount of funds and research on prediction and understanding earthquakes.
Hmm.
Geophysics is a branch of physics
Okay.
that deals with the propagation of seismic waves through elastic media. Now, depending upon the formation of the underground fault rock stratifications, those seismic waves travel at a different speed.
Hmm.
I have used those in two dams, Butana Dam in Alaska, where we were finding excess of a dam which was considered to be at a wrong place. So we have to use those to find out the right access. And then another dam, which is Bay Area's San Pablo Creable Dam, which has been sliding and failing. I was a principal investigator there. I also used. Not going into the details, I'm focusing on how we apply it. What we do with this thing on the surface, we put a hole and strike a dynamite pretty
Okay.
strong. It sends waves, so-called seismic waves, down to the ground. And the speed which they travel, different stratification, they are picked up so-called geophones. And the speed and velocity, there's a calculation, there's a degree by which we can tell you this strata is this is bad, this now is a rock, and oh gosh, this is a sudden disruption speed. There has to be a fault. Uh, so location of faults, and also this is something may be talking prematurely because instrumentation is going on, deep holes, the development of strains. By the time the interface at the two rock surfaces with the fault is development of strain energy to a point when the rock finally breaks and the swing back like a giant bell,
Okay.
sending waves which we call seismic waves, which a normal person would call earthquake. Now, development of those strains, reason is this: rocks on each side of a fault line, they are jagged, they're truths kind of teeth, they're locked in. But one of the rock is moving because down below there's a mental and there is a what you call drag forces that try to move, like Pacific plate try to move relative to American plate by San Andreas fault, keep moving, but they don't move actually. They keep developing strain, elastic strain. Will come a point when their atlassian breaks and they swing back and cause. Now, they are hoping the physics will help the change in strains will change in the property of the rock, and change in property will change the seismic waves which under geophysics. Now, I say it's premature. I don't know how far they'll succeed, but definitely to point out how the application of physics through
I
its
see.
subfield geophysics is helping to study earthquakes and their phenomena. That's all I could add on that.
Oh, that's fantastic. That's fantastic. And for sure, we're going to see a lot of this at SIPS, right? So anybody
Correct.
who's
This is
interested
this is what is the tip of iceberg. What we're going to see at the Virk International Symposium. These are some of the subjects that Professor Virk and Professor Singh have been working. Professor Virk also explained some of the papers that will be presented, some of topics, scientific topics that will be presented at the Virk International Symposium. So again, the symposium is open to anyone. And you do not need invitation, but sure, we can provide the invitation if somebody wants an invitation. If anyone has a discovery, if anyone has a new technology, if anyone has a new application of physics in various aspects of life, related to life, or even if it is purely theoretical, he is welcome. When I say purely theoretical, I'm just let me from my experience. I was participating in a conference in Mexico some times ago, and it was this Russian professor, very very well known, and then he basically got a piece of paper before starting his lecture, a letter format. He just made it like this and said, now my presentation will model this.
interesting. Interesting.
So this is purely theoretical. And I ask, where can we apply? Where can you apply this model? Because you just made it like this and you are modeling this. Where can you apply it? For the moment, there is no application. That was the response.
Yeah.
So, but still, you never know. In the future, this can be applied. So we welcome anyone without second thoughts. So we
Dr.
don't
Florian,
look
a
back.
curiosity about this.
Yeah.
In 2010, Professor Andre Geim, Nobel laureate, won the
Yes.
Nobel Prize for physics. Yes. 10
Yes.
years before, he made a frog levitate and he was ridicularized. He won the
Correct.
opposite, the Ig Nobel Prize in the year
Yes.
2000. And they said, why make a frog levitate? I mean, this technology is now used in super high speed trains. Yes. So he levitated a frog, and now trains are levitated using this technology. So there's nothing ridiculous about science. Maybe you
No.
cannot foresee the applications, but it's always great to have this scientific environment. Don't you agree, Professor Virk?
Yes, this is true. And, lot of discoveries have been made by people, Tesla and Edison and C.V. Raman. His students were surprised. He could, he wanted another Nobel Prize for discovery of the reason of the color of the sea, color of sky, and he wrote a book, Physiology of the Vision. But Americans, they did not agree. They say, oh, then he wrote another theory about, solid state elastic waves as Singh was. So people are really young people. I feel in developing countries they have a lot of potential because now things are available on internet, and you need not
Yes,
go for Berkeley, or you can study. Everything is available. So I find in my family with 7 grandchildren, they challenge me. Our eldest grandson, he is already doing job in Silicon Valley. He says, "Grandfather, I will beat your records." And in high
great.
school, he was very good in physics. So based on physics, he went to engineering in Toronto. He got Oxford scholarship. He says, "I am now fed up with the studies. I want to do my own research." So young people have a lot of potential in all countries. And sustainability, I think this is the main theme which kept Dr. Florian floating for almost more than a decade after 2002.
For
And
sure.
he is in every conference, more than 50 symposia, and with a lot of new themes. Electrochemistry, geochemistry is also there, nanotechnology, but physics was missing. I was wondering,
Yeah.
the very, queen of the senses, as they say, even education is there, education for sustainable development. And I believe there should be a course in high schools on sustainability, as there is a course on environmental studies. So
Exactly.
this is
Exactly.
the futuristic, vision for the whole globe. So I'm really, I appreciate that he has so much stamina all over, going around the globe. He has been to India 2, 3 times,
Oh, he,
and
he he
today,
sure does. He sure does. He moves around. I mean, today he's in Japan. Last week, no, 2 weeks ago. Where were you, Dr. Florian, 2 weeks ago? I even get mixed
Uh,
up.
yeah, me.
yeah,
Well, 2 weeks ago,
Oh,
3 weeks ago,
Brazil
I
came
was in
like four
Brazil.
times this year.
Yeah,
Yes.
I
And
was
then
in
he went to
Brazil. Yes,
France, to Czech Republic, to, well,
yeah,
a
to
lot of places.
Austria, Germany,
Austria.
Czech
Yeah.
Republic. I don't.
He doesn't
I
stop.
lost
I
track
mean, he
of.
has
Yeah.
a suitcase ready to travel. Well, guys, we've got like an hour of chat already. I would like to
Yeah.
yeah,
have you
I
guys
think,
have your final consideration. So
Yes.
I'll grant you 2 minutes for your final consideration. So I will start with Professor Singh. Professor Singh, please.
Oh gosh, 2 minutes. It brought to my mind when Professor Virk and Professor Sukhmander saying, as a professor for teaching 36 years, out of them 9 years as a visiting faculty for short interval at Cambridge University, I want to bring it to your attention. At Cambridge, you're sitting there, the professor points out, they see the grass there, 600-year-old. I said, wow, I heard about it. Cambridge is so old. See the stone up there? Yeah, I see that. That's where the apple tree used to be there, where Newton saw an apple fall and came up with the gravitational theory. Oh, yeah, I heard it many times. Now the Professor Scofield, he's going to now sarcastically tell me, because I was from Silicon Valley. He said Newton didn't have to wait 1,000 apple fall to have a large database before he could think of gravity. The problem with the modern day research is this, that the enormity of information, we go too much of the data. The creativity and imagination is being clouded by the number of courses students to take and the number of run around the fever space, financial hardships. So is there a way, physics requires a lot of patience, fundamental research where they can dig deep. I know went out the engineering building and there was a big pond. Professor Schofield said, "Yeah, this is where the pond, where the Darwin spent 15 years observing frogs." So some of those people's, is that to have a fundamental research done, then we need to seek, first of all, those people who can commit for extended time to dig deep and all the availability of the equipment rather than rush to turn in a thesis or so. That's my 2 minutes. advancing the research, advancing those things, we need those. Secondly, I have observed between COVID and all those things, it looks like we are not respecting nature. Our infringement on the nature, those natural habitat, have given us those viruses. There is a clear incompatibility between so-called progress and human values. We have to somehow or the other be not disconnected with the nature, respect it, celebrate it, don't pollute it, so that we can learn a lot from nature by observing and also protecting our environment. That's my piney worth of peace in 2 minutes. Thank you so much for enabling me, for letting me participate in this conference. It was what a pleasure and what an honor too.
Well, we have to thank you very much because SIP sure gets much better with you with us, and thank you very much also for participating in this talk show because we could learn a lot. For sure, we're going to meet in Phuket, and we're going to. I would like to have a cup of coffee with you and discuss a little bit more about it.
Look forward
And now,
to that.
yeah, thank you very much. And now, Professor Virk, 2 minutes for your final considerations. Professor Virk.
You know, okay, my
Could you start again? Sorry, we had a
microphone was muted. Is it okay now?
Yeah, now it is.
Yes.
Now it is. Go ahead.
Yeah. I think I got the invitation. I don't know the reason how Dr. Florian discovered me in November 20. Then 21, again Corona, and 22, hopefully this Corona, scare has gone. And I was reading Thailand. We are now hoping to meet there in Phuket. As you say, when I returned to India after doing fundamental studies in particle physics, I was feeling quite pessimistic, not depressed, but pessimistic that how can I continue my studies. Then 77, I went back to ICTP, International Center of Theoretical Physics in Trieste, where Dr. Abdus Salam, Nobel laureate, was the director. I discussed my problem that I can't do fundamental research, but I have started some type of interdisciplinary research. He was helpful. He said, I will fund your applied research because it is need of the developing countries. Developing countries, they need the application of science. And at the end of almost 50 years of my career, scientific career, I don't regret my decision. The fundamental studies in physics, they can help you to apply your knowledge in all fields, computers, even economics. People with physics, they are doing modeling in economics and of course chemistry and other areas of science technology. So I hope sustainable development is also need of the hour. That is my final comment.
Well, thank you very much, Professor Virk. It's been a very great honor to meet you in person because Dr. Florian has spoken a lot about this symposium and about you. And thank you very much for participating of SIPS of Science. And I'm looking forward to seeing you in Phuket from the 27th of November to the 1st of December. And I want to have a cup of coffee with you too. And Dr. Florian, your final considerations about this magnificent show today.
A couple of things. So first, this is a combination. We spoke about purely theoretical science and application. Okay, we spoke about that 99% of academic publications stay in the shelf of the libraries without seeing the application. SIPS, one of the goals of SIPS is shortening this period or making the theoretical science come to reality. So if a fundamental discovery today might take a century to see the reality because it is published in very specific journals, in very specialized journals that other scientists of other fields do not look at it. So SIPS bring together in one roof all field of science. So the chances that a fundamental science today, the period between the discovery and the application shortens a lot. So if you want to find application for your new discovery and theory, although it is so theoretical, come to SIP, and the chances are that the light of application will come much faster for this discovery, especially in physical discoveries, because every field of science, every field of all players are in one roof. Now, Professor Virk mentioned Corona. So since coronavirus disturbed a little bit, the organization of SIPS, so now, Phuket is completely open. You don't need PCR test. I think we have everything, all the news, latest information in the website. You don't need a PCR test. You can show only vaccination, but also people that are not vaccinated. So, all of the chances are equal. Those that are vaccinated and those that are not vaccinated. Those that are not vaccinated, they need a PCR test. Those that are vaccinated, they do not need the PCR test. So everybody is open to come without any hindering, and the procedures are fast. In case that there is a sickness, that in case of somebody gets a virus or there is a monkeypox or whatever, so the hotel will refund upon medical note from the doctor. So there is no risk to book the hotel, which is, by the way, I'm going to go there, one of the best hotels in the area at beachfront. Also, this point that I mentioned in the beginning, you mentioned P. P stands for paradise. That is one of, you remember in the beginning, this is one of the criteria of sustainability, quality of human life. And engineers and scientists, basically, the criteria of quality of human life has been forgotten, has been kind of out of the window. So basically, the scientists are not recognized that they can enjoy the best places in the world because they are not paid as much. And SIPS is giving this opportunity to be at the best places in the world for scientists and engineers because they deserve it. They are the main development of the main developers of the society. Their contribution to the society is much bigger than any other field. So, but the credit they get is lower than they should, and then the quality of life they enjoy is not as other professions like movie star and TV stars. That we all respect all professions, but this is we are under the scientist is under evaluated. So that's why we choose the best places in the world for scientists and engineers. In order that science has the background, as in my background here, the best nature. So it is when you have scientific discussion and presentation in the top scientific program in a background of the beautiful nature, the efficiency of discoveries, and the new ideas, when people feel good in a beautiful nature, they skyrocket. So the number of new ideas, number of cooperation projects between countries, between fields of science, and between different culture, so they multiply, and this is the history of SIPS. So many different cooperation between different science, different countries, etc. SIPS, build bridges between cultures, field of science. Science is one. We have divided the science because of our ignorance in physics, chemistry, in electrochemistry, whatever. Science is one, but we have divided it because of our ignorance and our limited knowledge. Now SIPS brings them all together in one roof, in converge. But that's why one of the criteria of accessibility is quality of human life, and the SIPS chooses the best places in the world and for a cheap price. All our hotels are 5-star hotel, but the price we are giving is almost half almost 3-star, 4-star hotel. And this is specifically for science engineers, because they deserve it. It is not, it is intentional. It's not by chance the choice of the best hotels in the world, and for a very cheap price, because we have a very good deals. And not only that, but this serves as incentive for scientists and engineers. So,
Very good.
and here, since we are here, I am in Japan. I am in
about where you are. Just a second. We
Yeah.
got a message here from Adalto saying that you are showing us a beautiful place. Tell before we end, what's this behind you? Because it's really beautiful.
Well, I am at Shirahama Beach in Wakayama, Japan. This
Okay.
is one of the most famous beach in Japan. It is Hokkaido. Sorry, no. This is where we can say is the best beach, because it is a beach, it is a white sand, and also it is the best places to have onsen or hot spring waters that are good for the health. So this, you have it in one place. You have it exactly in one place. That's why this place is one of the most famous in Japan for the beach. And I'm right now here at Marriott Hotel in the beach, at Nanki Shirahama Marriott Hotel. And
How
this
do you
is
call it?
one of the.
How do you call it?
It's Nanki Shirahama Marriott Hotel.
Okay.
Shirahama is a city name. Nanki
Yes.
used to be the hotel name before they came under Marriott umbrella.
Oh, I see.
So it's a Marriott Hotel, Nanki Shirahama Marriott Hotel, and this is one of the best hotels in the 11th floor. You have onsen, you have natural spring waters. So, and then you can see the same. It's a much better view that you can see behind my back now. So it is one of the best hotels and in the best areas. And this is one of the candidates for our future SIPS. I have here with me, and just wanted to thank him, the sales and marketing manager of the hotel, Mr. Kitahara. I just wanted to thank him by bringing him on the stage. This is Mr. Kitahara, which is sales and marketing manager of Marriott Hotel, and I want to help him to thank him for giving this opportunity to have this. I see the same thing from my room, but when you are in a room with a light in the background, basically you see nothing.
Yeah, exactly.
That's why we choose this place, and I thank Mr. Kitahara for this opportunity.
So tell him to prepare a nice room for me when we have SIPS there, because it's going to be a great. It's going to be really fun, because I saw we're going to. If anybody's interested in knowing more about where Dr. Florian is, you can go to Flogen Star Outreach YouTube, and you're going to find there a video. Yes, a series of videos we have exclusively for Flogen that is called The Art of Science. And if I'm not mistaken, it's number 5, Art of Science, Japan, number 5, right?
Yes, correct.
Yes, so you can see
this
what
is
Dr.
the
Florian
number 5 in Japan.
Yeah, we are going
so
to
I'm
put
saying,
the link here also. It's not posted now, but we are going to put the link underneath so anybody can watch it. I'm going to place the link right now.
Arigato.
Very good, Dr. Florian.
So he's saying he's coming. He'll visit the hotel.
Very good. I'm going to put the link while you're speaking, Dr. Florian. I'm going to put the link on the broadcast in the comments. So if anybody wants to watch, the Art of Science, Japan, number 5. And so if you want to watch where Dr. Florian is and where SIPS might be soon, maybe in 2 years?
2023 or 2024.
2023.
We make the plans long in advance.
Okay. Very good. Well, I would like to thank all of you for being part of tonight's show. Yes, it was a pleasure having Professor Hardev Singh Virk and Professor Sukhmander Singh. Thank you very much. And I'm looking, as I said, I'm looking forward to having a cup of coffee of both of you
Thank you.
in Phuket. And I would like to invite all our guests here tonight, or all our viewers, to subscribe the channels, both Flogen Star Outreach and also TV Onda Azul. And we are going to be there, and we're going to have a special broadcast from Phuket. We are the official broadcaster from for SIPS 2022, and I'll be honored to have all of you there. It's a pleasure having you. And every Thursday at 10 p.m. GMT in Rio de Janeiro, it's 7 p.m. In California, it's 3 p.m. And in Japan, it's 7 a.m. So wherever you are around the world, just check what time it is, GMT, 10 p.m. GMT. Every Thursday here, we're going to be talking about science, technology, sustainability. We're going to be talking about SIPS, Sustainable Industrial Processing Summit and Exhibition. Thank you very much. I'm Mario Linhares. I'm broadcasting from Rio de Janeiro, and it's a pleasure having you here. See you next Thursday. Arigato. Arigato. Sayonara, right? That's what you say.
Arigato gozaimasu.
Arigato gozaimasu.
Gozaimasu. And how do you say
remove the
goodbye
mask, people to understand you.
Hindi?
So now you see his own face, because they still public servant in the hotel. They keep the mask. But now you are.
Very good. So bye everybody. See you next Thursday. And this is SIPS of Science. It was an honor having you here tonight. Bye.